My dear students and learners, this is my fifth video of engineering thermodynamics course for the first unit, in which we are going to discuss about reversible and irreversible process. Okay, so you know very well it is very essential to review the things which we have come across during the last four videos. Is about what is state, system, kinds of state, and kinds of system, boundaries, surroundings, process, path, equilibrium, thermal, mechanical and chemical equilibrium, thermodynamic equilibrium, what is the importance of quasi-static process, etc. Okay, so now already in the last video I have started this thermostatics is nothing but instead of thermodynamics, this course, a particular course, can be named also as thermostatics, since here we are dealt with the system whenever it come across or crosses the condition of statics, that is equilibrium condition. Okay, so we are plotting the properties when we could able to measure is the condition of equilibrium, right? Okay, so equilibrium is only given importance in this subject. So instead of thermodynamics, dynamics means movement, as already we have seen. Dynamic means moving from one state to another state, or conversion from one to another form, right? Okay, so here instead of thermodynamics, we can call this subject as statics, since we are giving more appropriate things to equilibrium conditions. So thermostatics would be a more suitable title than thermodynamics. This is for just a clear view about this subject, not by terms of name. Okay, a reversible process. It would be so interesting to know about this reversible process. Okay, a reversible process is a process if the system passes through a continuous series of equilibrium state. As already I have explained during the quasi-static process, if you can able to grow in the reverse direction, or as you have seen some in some of the films, by the time machine you can able to go to that particular childhood or college timing, like that. If you can able to go back, if the system or any reaction can have the possibility of going to the reverse direction without any traces of that particular reaction effect, without any effect on the system, means then it is that reaction or that path of the processes is called reversible. Okay, reversible process is only can be shown as a locus of a series of sequential processes, because they have undergone with the equilibrium condition, because they were conducted in a very slowly manner. Okay, infinitesimal slowness, then only you can able to trace the path which has crossed, right? Okay, so how you can analyze the things, how you can study the things? If you get the data from that system, how will you get the data? If you have the possibility of measuring and identifying and noting down the things, right? Okay, even if the simulation, given anything, if you want to collect the data, means that system has to given it that much the reaction should takes place. Okay, it should not trace or leave any identified change in the system. Okay, then it is called reversible process. A reversible process is then shown by a line drawn through the points representing the equilibrium states. And what are the various conditions needs to be satisfied if the process wants to be reversible? Means no friction should present. Okay, so here itself you can very much know that there is no any practical possibility of getting the reversible process for uh, physical things whatever you are saying, because no friction means no world, no universe, no movement, no stability. Okay, no heat exchange to or from the system. If there is heat exchange means automatically the properties would be changing in the system. It will have the effect on the system. If the system has effect by conducting that particular reaction means then it is not a reversible process. So no heat transfer should be present. It should be quasi-static. Quasi-static means infinitesimally slowness is needed to get the process to be reversible. Okay, so these three conditions will aid you in the light of reversible process. Okay, characteristics of reversible process, Saya have explained. It can be carried out in the reverse direction along the same path, and it should not leave any traces of its occurrence in both system and the surroundings. And it could be executed in either direction, forward and as well as reverse direction, without violating the second law of thermodynamics, which we will discuss later. And no wastage of energy is accompanied. That is, if there is no effect on the system, you are running the fan daily, you are running in such a way that it is not getting rusted, dusted by any of the system. You are running it in a very slow manner, in such a way that how you have fitted that fan in the first day, the fan looks like how it was when it was fitted during its first day in your home. Okay, after 10 years if you see, that should be looking like that. Okay, so no wastage of energy is accompanied with this system, and hence maximum efficiency could be achieved from that reversible process. And it absorbs minimum input energy. Of course, you come to know that with minimum input it will yield maximum efficiency only by the way of conduction of that process reversibly, infinite slowly, quasi-statically, without any effect. Okay, so degree of reversibility is tells about a measurement of perfection in any thermodynamic transactions or reactions. And this reversible process is used to set the criteria of standard efficiency, or when you are conducting the reactions with the, or processes with the reversibility, means you can able to take the efficiency which is found out or delivered by that system is the standard efficiency or the maximum efficiency compared to other system, and it can be fixed as a datum for other processes. Okay, same type of processes. It is a hypothetical or ideal process, means it cannot achieve practically, which can never achieve in practice. Okay, examples is means motion without friction. If there is friction, there will be effect, there will be wear and tear, there would be some traces of effect from the friction, right? Okay, so no reversibility. Restricted and controlled expansion. Restricted means very slowly if you are doing the expansion and compression in such a way that each and every point crossed by the reaction or the process is quasi-static. Isothermal and frictionless adiabatic process. Frictionless, isothermal, constant temperature maintenance. Isothermal means temperature is maintained constant during that adiabatic process. Means restrained discharge of your battery. Okay, and elastic stretching of your solid. Again, that solid could be able to come to its initial position if there is no any elongation or change in length of the solid, means then it could be taken as reversible process. Same, all the versions explained in a reversible process are directly opposite in this irreversible process, in which it is the system passes through a sequence of non-equilibrium states, and here the values of the system are not the same value or unique value, which would be changing, keep on changing then and there. As a result, you cannot locate in any property coordinate. That is most important. Here you cannot get or plot the PV diagrams or TS diagrams, and whatever may be the property coordinate could not be fixed or drawn if the process is irreversible. Okay. If it is executed in the reversible direction, the original initial state cannot be reached. How is it possible? It got hurted. Okay. How can you get the new thing again? New system again without any point of effect? Okay. The properties are definite only at initial and final states. Initial and final states are good, but the path crossed by the process were not up to reaching the reversible process. Okay. Characteristics are carried out in only one direction, that not leave any permanent changes. It leaves a permanent change, and it could be executed in either direction, could not be executed, and more wastage of energy with very minimum efficiency can be achieved by this process. And of course, this is the highlight and the result, that all the natural processes or spontaneous processes, all the practical processes are taking place in irreversible process only. They are having some finite speed. Infinite slowness is not possible. Okay, whatever occurs in the nature, whatever you are seeing physically, all are irreversible process. The fan could not be taken after 10 years. It could not be fine the same as when it was fitted. You cannot go back to your childhood days. Okay, so it is passing through finite discontinuities, means there is no any uniform property maintenance. Okay, so resulted with the degradation of energy, resulted with the quality, decrease in quality of the energy. Okay, so example, all the spontaneous chemical reactions, flow with friction, fluid flow with friction, electric current with resistance, diffusion of gases, mixing of dissimilar gases will get the effect, some other effect, and free expansion and throttling process will be explained soon. Okay. So here you can see the reversible process means slow expansion takes place and the pressure distribution is even here. If it is irreversible process means fast expansion and the work is delivered here also, but here you can see here the pressure distribution is very even, but here you cannot able to get the trace as in reversible process. Okay, so here work during the work done during the reversible process is higher than during the irreversible process. And here also you can able to see during the compression it was same. During the compression, if you are doing it in the faster manner, then you can able to get the that is more work done during the reversible process. But anyhow, during the reversible process, the slow compression yields a lesser work done. Okay, that is, it delivers the maximum work but consumes very least work. Okay, that is here less input, higher output. Okay, this is the questionnaire section which you can answer and find out the answers. We will discuss it in the next video. Okay, and let me continue in the next video. Thanks for patient listening. I am Dr. Suja and discussing about engineering thermodynamics. Thank you.